Let's take everything that we've been working on so far and let's put it together. And we're going to put it together to do something called optimization. In optimization questions, we're going to be asked to find a maximum or a minimum. So let's think back to James and his stuffed animals. This is an example that we've taken up in class. So James collects stuffed animals. He collects teddy bears and dinosaurs. He has a minimum of 10 stuffed animals, and he has a maximum of 20 stuffed animals. He knows he has less than or equal to 6 bears, and James has at least 5 more dinosaurs than bears. He estimates that each bear is worth $10 and each dinosaur is worth 15. What is the maximum value of his collection? So what we're going to do first is define our variables. So when we're defining our variables, what we need to do is say, let x equal something and let y equal something. So in this case, let's say, let x equal, well, we're interested in how many bears and how many dinosaurs he has. So we'll let x equal teddy bears because that's mentioned first. So let x equal the number of bears. And we'll say, let y equal the number of dinosaurs. Now we're going to take all of our sentences, except the sentences that have to do with money, except the ones that have to do with the maximum value of his collection. We're going to hold off on that last one, but we're going to use all the other ones and translate our words into inequalities. So here was our first step, defining our variables. Our second step is words into inequalities. So our first sentence, he has a maximum of 10 stuffed animals. Stuffed animals, we're talking about the total number of bears and dinosaurs. So we have x plus y. If we add the number of bears and the number of dinosaurs, he has to have more than 10, or he could have 10, right? He has a minimum of 10 stuffed animals. So he has to have greater than or equal to 10. The next sentence, he has a maximum of 20. So again, we have our x plus y because we're looking at our total number. Maximum means he has to have less than or equal to 20. Next sentence, he has less than or equal to 6 bears. We're only talking about bears here. So we have x less than or equal to 6. Here's our most complicated sentence. He has at least 5 more dinosaurs than bears. So we're comparing dinosaurs and bears. So in this sentence, dinosaurs comes first. So I'll write y. We're comparing y, dinosaurs, to x, bears. At least means greater than or equal to. 5 more means plus 5. And we know he has more dinosaurs, which means our plus 5 doesn't go with the dinosaurs. It goes with the bears, the one we have less of. So x plus 5. Now remember, we always have 2 other inequalities when we're dealing with optimization. He can't have a negative number of bears, and he can't have a negative number of dinosaurs. So we're always going to write x is greater than or equal to 0, and y is greater than or equal to 0. Even though those aren't mentioned explicitly. And I'm going to number these as well. So 1, 2, 3, 4, 5, and 6. Now let's rewrite some of these in our y on one side, ax plus b on the other side form. So this one, if we subtract x from both sides, I'm just going to write an arrow. We're going to change this into y greater than or equal to negative x plus 10. I just subtracted x from both sides. I'm going to do the same thing to this down here, subtract x from both sides, and we'll be left with y is less than or equal to negative x plus 20. This doesn't have any y's, so we'll leave the x isolated. This is already in the right form, as are these two. So our next step is to graph all of these lines. Now, when we're graphing, I'm just going to erase these here. And let's write in some new numbers because we don't need it to go up to 10. We actually need it to go up to 20. So let's instead go up, instead of going up by ones, let's go up by twos. So this one is 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And we'll do the same thing on our y-axis. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Now we're ready to do some graphing. So our first line, our starting point is 10. So here's 10, and we're going down 1 and over 1. So we could think about going to 9 and over here, and we're in the middle somewhere, or we can think about going down 1 full line and over 1 full line. And we'll get the same line no matter how you graph that. Greater than or equal to, so we're talking about a solid line here. So let me get a line set up. Here's a line, and let's graph that. There we go. Now, if we think about it, we know that we're going to be shading above this line because it's greater than or equal to. So let's shade, let's do a little bit of shading. We'll do this one in red above the line. So we know, I'm just going to put in little arrows here because it'll be a little bit easier, a little less messy if we just use some arrows rather than shading a whole bunch. So there's our first line. Here's our second line. Y is less than or equal to negative x plus 20. So our starting point is 20. And again, we're going down 1 and over 1 to our second point. Let's graph that line. There we go. And less than or equal to, so I used my solid line, and we'll be shading underneath that. So let's draw some green arrows so that we know here we're shading under this line. So already we can see that our shaded area is going to be somewhere in between these two lines. Let's keep graphing. Our next point is going to be, our next line is going to be x is less than or equal to 6. So we don't have any y's this time, which means we're starting on our x-axis. So we'll put a point at 6 on our x-axis, and we're going to draw a line straight up and down. So from here, we're just going to go straight up here. This one, we're shading, because it's x and not y, greater than would be our numbers of x that are bigger than 6, less than the numbers of x that are less than. So when we have only x, less than is to the left. So here we're shading on this side. So we further narrowed our area that's shaded by all of them to be in this area right in here. So we've done lines 1, 2, and 3. Let's take a look at how line 4 changes things for us. Line 4 is x is greater than or equal to x plus 5. So our starting point is 5. It's halfway between 4 and 6, even though it doesn't have a line. That's okay. And our slope is 1 over 1, right? Because there's nothing in front of our x. It's like there's a 1 there. So 1 over 1 is our slope, which means we're going up 1 and over 1. So I'm going to go up 1 full space, so to here, and over 1 full space to here. So there's our second point. We need to graph that line. So we'll connect these two dots. And we want it to be greater than, so we're shading above that line. Let's see what other colors we can use. maybe a purple. So we're shading above this line, which means we're shading up in this area. So again, we've further restricted where all of our overlapping shading is, right? The red arrow up here, green arrows, blue, and purple. So we're somewhere in here. We have 2 more lines to draw. And in this case, it's really important that we draw at least one of these. We'll draw them both just to make sure that it's there and that we're being complete. So x greater than or equal to 0. Again, we go to the x-axis to 0. We're going to do a line straight up and down. Y is greater than or equal to 0 is along the x-axis at 0. So I'm going to draw both of those lines in at the same time. So here's our line. X is greater than or equal to 0. It's a little hard to see because it's right on the axis. And then here's the line, y is greater than or equal to 0. Again, it's right on that axis. If we're shading it, we're shading above this one. Well, that's okay. We don't even really need to draw in our arrows because all of the shading that we see right here is above this one. And especially all of the shading where it's all overlapped is clearly above this. So we don't have to worry too much. This last line, the x is greater than or equal to 0, this becomes important because this becomes the last line for our polygon. So let's put little arrows in as well. Maybe some turquoise arrows this time. And we'll draw them greater than, so we're heading to the right. So the area that's overlapping shading, right, where all of our shading happens, is in here. So we start up here. If we go down this line, over to this line, up, turn the corner, and continue on here, right? So everything in this area that I'm coloring in green right now is where the overlapping shading exists. So this is our polygon of constraints. Right? Now remember, we find our polygon of constraints because we care about the vertices. So we care about the points that are the corners. So here we care about A. Ooh, that's kind of big and hard to read. Let's erase that, make it a little bit smaller. Here's our A. Here's our B. Here's our C. Here's our D. Right, we're just labeling each corner, and there's our E. In the next video, I'll pick up at exactly this point where we have our shading and we have our vertices labeled. And we'll look at what we need to do after this point in terms of solving our optimization question.